Myself Shubham Singh, and I have completed my MSc in Chemistry from University of Delhi. When I was in MSc, I was associated with a research program with DRDO, where I have learned a lot of practical applications of chemistry and the way we can use it in our everyday life. I want to incorporate my knowledge with the students so that I can just bring a change and make them successful in their particular examination and in the competition. And not only the examination, but I just want to make a difference in their nature and so that I can make them a better human being through my subject knowledge and my inspiration to them. I just want to join your team because it is such a big name in India and where I can get a lots of opportunity, learning opportunity and the guidance from such a good team so that I can understand where and how I can incorporate my knowledge and my experience to these aspirants of and the future of our country. So this would be a very good chance for me so that where I can showcase my knowledge and experience and could be a good beneficial to your team and to the society also. Thank you. So, very first, I just want to start with a topic that is molecular orbital theory. It is a very important topic where it is very difficult to make students understand what is molecular orbital theory. At very first, we learn about the Vesper theory. First, VBT, valence bond theory. After understanding valence bond theory, students get to learn that there are drawbacks of valence bond theory. After that, the hybridization concepts come into the effect. And when they start learning about the hybridization concept, they're thinking this is the method and how with the formation of bond taking place between two atoms. But again, there is a new theory that is molecular orbital theory, and where students start losing their interest in chemistry because when they understand that there we have learned two other theories about bonding of two atoms, and we are again they are having the drawbacks and shortcomings, and then we are again going to learn the molecular orbital theory. What is happening in chemistry? So chemistry doesn't want to confuse you or at all. Every theory have their part and their role in the chemistry and predicting the orbital and the nature of a molecule. So when hybridization theory got failed, hybridization theory couldn't explain the paramagnetic nature of oxygen. Hydrogen hybridization theory couldn't explain the He2 non-existence of He2 molecule. So there comes a new theory come into the effect that was molecular orbital theory. The most important part of the molecular orbital theory, which uh, a new concept came into the effect, was in the hybridization and BBT. It was only the electrons were around made to be around bonded uh, around a single nucleus. But in molecular orbital theory, it was must take in the consideration of multiple nucleus at the center and electrons around them. So there forms molecular orbital theory. So I'm just going to take a example of hydrogen and hydrogen going to form H2 molecule. First, I'm going to talk about atomic orbital of hydrogen molecule. So I'm just going to make it simple. Two atomic orbitals combines to form new molecular orbital. So atomic orbital where atom stays in an atomic form. When they come close to each other, they form new molecular orbital where electrons can reside. अगर हम example ले, there is a very simple example of it that uh, if we are having a certain home, if we are having home, there are two parts of the separate home, like this room and this room. So if we have a home, सिंपल इन लैंग्वेज दैट टू, अगर हमारे पास घर है, हम घर लेते हैं, हम क्या करते हैं कि हमें दो घर, डिफरेंट घर मिला, ठीक है, हम दोनों घर को क्या करेंगे, वी आर गोइंग टू कंबाइन इट एंड फॉर्म अ न्यू होम, सो डैट वेयर टू फैमिलीज कैन लिव विथ ईच अदर। जैसे हमारे भाई है, हमारी बहन है, तो हम क्या करेंगे कि इनका अपना, इस भाई का अपना घर है, इस भाई का अपना घर है, क्या करा दोनों ने, दे break the walls of two different homes and form a new home। तो ऐसा ही होता है हमारा एटॉमिक ऑर्बिटल्स में, दो डिफरेंट एटॉमिक ऑर्बिटल्स, दे फॉर्म अ न्यू मॉलिक्यूलर ऑर्बिटल, जहां पे वो एक नया अपना घर बनाते हैं जहां पे वो रह सकते हैं। सो when they form a two new molecular orbitals, one is bonding molecular orbital and another one is anti-bonding molecular orbital। So we are first going to understand what is molecular orbital, and then we'll come over the bonding molecular orbital and anti-bonding molecular orbital। So what about, let's talk about molecular orbital। So molecular orbital can be defined as a region of space comprising the nuclei of combining atoms around which there is maximum probability of finding the electron density। So what I just want to convey that molecular orbital are those orbitals where we can find the electron, uh, likely to find the electron in large quantity. Like there is the maximum electron density in that particular area where the most of the electron will going to reside. That will be our molecular orbital, and yeah, that will be our molecular orbital. So how this theory came into the effect and why it is, how we explain the molecular orbital and bonding molecular orbital and anti-bonding molecular orbital. So let's talk about first LCAO concept, that is linear combination of atomic orbital. Okay, so from this we have learned the formation of bonding and non-bonding molecular orbital. Here there goes with a graph that, okay, before that we know that Schrodinger wave equation. Schrodinger has defined that orbitals are just the energy level where electrons reside, and it is having the wave function, orbitals having the wave function. So we define wave by psi, which having some amplitude, all waves having some amplitude, and we define that amplitude by psi. So first let's talk about molecular orbital, sorry, formation of bonding and non-bonding molecular orbital. Here we go. Here we have a wave function, and I'm going to define it through a wave, and this is our psi a, that is amplitude. We also call it probability amplitude. Psi is defined as probability amplitude, and in Schrodinger wave equation we have already learned that psi is having no practical application, no practical existence. Okay, so further we are going to understand that how psi is related to this molecular orbital and electron density. Okay, first I'm going to have two different waves, and these two different waves I just want to explain what are these two waves. These two waves are two different atomic orbital. These two waves are just two different atomic orbital. Let's suppose psi A is an atomic orbital and psi B is different atomic orbital. So if we are going to mix them, two waves are going to mix with each other. When two waves mix with each other, they form two different type of uh, when we combine two different waves, we got one constructive interference and destructive interference. So we have learnt in physics that the the when two waves intermix, they shows interference, and there are two types of interference. That one is constructive interference, and second one is destructive interference. So first, I'm going to talk about intermixing of these two waves and forming a constructive interference. So very first, let's talk about constructive interference. So here we have the constructive interference. I'm mixing two different orbitals. I am mixing two different orbitals. And when two different orbitals will mix, and it will form a orbital, new orbital, and this orbital, add in the constructive interference, will have more amplitude than previous two amplitudes. Why? Because we are adding the amplitude. We are adding the amplitude. So this is our psi b. Another one, this is psi a. And if I'm going to talk about this bigger one, this is having psi a plus psi b. What is psi a plus psi b? So this gives the constructive interference. If I'm going to talk about destructive interference, here only. So here the new amplitude which I'm getting would be less than previous two amplitudes. Previous two amplitudes. And this gives us as psi A minus psi B. So here we are, when we have intermixed two different orbitals, we are getting first psi A plus psi B, and second interference gives a new amplitude, that is psi A minus psi B. So very first I'm going to talk about psi A plus psi B. So I've just talked about Psi has no physical significance. But what about psi square? Psi square means probability density. Psi square means probability density. And if we are going to talk about probability density, it's talking about the probability density of electron to exist in that particular area. So if I'm going to talk about psi square probability density, so when we two orbitals intermixed with each other, it is forming a new orbital or a new molecular orbital where two different orbitals are mixed to form a new orbital. अगर बहुत अच्छे से एग्जांपल लेते हैं हम, चलो फर्स्ट आई एम जस्ट गोइंग टू सॉल्व इट फॉर यू. Psi a plus psi b whole square. We everyone knows that a plus b whole square gives psi a square plus psi b square plus 2 psi a psi b. See what I am getting here. Perfect thing, a perfect to understand that we are getting 2 psi a plus psi b. Here, if I'm going to talk about psi a square, this is the probability density for first orbital, first atomic orbital, and psi b square, it is probability density for second atomic orbital. But what is this extra 2 psi a plus psi b? It means that when two atomic orbitals are mixing together, we are getting some extra place where electrons can reside. अगर हम एग्जांपल ले अपने घर का, घर में जब हम फर्स्ट फ्लोर या सेकंड फ्लोर की बात करते हैं तो वहां पे छोटे छोटे कमरे बने रहते हैं. ठीक है, जब छोटे छोटे कमरे बने रहते हैं तो हमें क्या लगता है यार जगह बहुत कम है, जगह नहीं है. क्यों? थोड़ी थोड़ी जगह कम रहती है, ऑब्वियस सी बात है, दे आर सर्टेनली डिजाइन. अब इफ यू आर नॉट गोइंग टू प्ले क्रिकेट इन द किचन, ओके, एंड यू आर नॉट गोइंग टू प्ले किचन इन द वॉशरूम, सो जैसे ही तुम छत पे जाते हो, जैसे ही हम छत पे जाते हैं, फिर वहां पे हम सारे कजन्स दोस्त भाई वगैरह सब मिलते हैं और वहां पे मान लो हम क्रिकेट खेल रहे हैं, ठीक है, या कोई भी हम अपना गेम खेल रहे हैं. अगर हम छत पे जाते हैं, छत पे कोई भी कमरे नहीं है, वहां पे क्या हुआ, सारे जितने भी जो छोटे छोटे रूम्स थे, एज्यूम इट एज अ एटॉमिक ऑर्बिटल, ठीक है, वो जितने छोटे छोटे रूम्स थे वो एटॉमिक ऑर्बिटल है. इट जस्ट हमने क्या करा, सारे एटॉमिक ऑर्बिटल्स को मिक्स कर दिया और एक नया मॉलिक्यूलर ऑर्बिटल बनाया. तो उस मॉलिक्यूलर ऑर्बिटल में हमें क्या मिला कि अरे वाह, हमें बहुत एम्पल ऑफ स्पेस मिल गया. हमें क्या मिल गया? एम्पल ऑफ स्पेस. दैट इज जो एम्पल ऑफ स्पेस मिला हमें, दैट इज 2 psi a plus psi b. ठीक है, फॉर एन इलेक्ट्रॉन ऑल्सो 2 psi a psi b is just an extra place where electrons can reside there happily. That is constructive interference. Now I am going to talk about destructive interference. Here psi a minus psi b square, it forms psi a square plus psi b square minus 2 psi a psi b. What I have just seen here, just try to understand. Here, in destructive interference, atomic orbitals were happy in their psi a and psi b. They were happy. When these psi a and psi b combine together, then the space where electron could have been reside have just reduced by 2 psi a into psi b. So just assume that जो इलेक्ट्रॉन के रहने की जगह थी वो अब कम हो गई ड्यू टू डिस्ट्रक्टिव इंटरफेरेंस. ऑब्वियस सी बात है, मान लो एक घर है, क्या कर दिया, डिस्ट्रक्शन हुआ वहां पे. अब डिस्ट्रक्शन की वजह से क्या होता है, मान लो ऑब्वियस सी बात है, कंस्ट्रक्शन करने से पहले हम क्या करते हैं, डिस्ट्रक्शन करते हैं. वहां पे जब हमारा क्या हुआ, डिस्ट्रक्शन हुआ, डिस्ट्रक्शन की वजह से क्या होता है, दीवारें गिरती हैं, सब कुछ गिरता है, बिखरा बिखरा पूरा रहता है और वहां पे हमारा रहना नहीं हो पाता. तो अब हमारे पास क्या हो गया कि पहले जो हमारे पास ज्यादा रूम थे, एक पर्टिकुलर क्या हुआ, डिस्ट्रक्शन की वजह से कम हो गया. सो बस हम समझने के लिए इस चीज को हम थोड़ा सा समझ रहे हैं कि एग्जैक्टली ऐसा होता नहीं है, बट हाँ, just to make it more understandable to you, I am talking taking the example of destruction. So psi a minus psi b means destructive interference when taking place. What we are going to have? A less area where electron could reside. Understood? Okay. So now we are talking about, see, psi a square is also called as bonding molecular orbital. Okay. So we can say that psi ab square is equals to psi a square plus psi b square plus 2 psi a into psi b, and same for the other one. So what we are getting, just an extra space, that is extra 2 psi a psi b to reside here. Got it? Now I'm going to talk about the shape of the orbital, the shape of the bonding molecular orbital. So we have just understood what is the constructive interference and destructive interference. So hence, this constructive interference forms bonding molecular orbital, and this destructive interference forms anti-bonding molecular orbital. Understood? Now we are going to understand more about this in the shape. So shape of atomic orbital. Let's assume when two s orbitals are intermixing. When two s orbitals are intermixing, we know the shape of s orbital is spherical in shape. So we have atomic orbital of s subshell. Sorry, s orbital. Atomic orbital of s. It forms. So this s orbital will undergoes the formation of by constructive interference and destructive interference. What is this s orbital? What is this s orbital? We have already understand in the Schrodinger wave equation that this s is only the probability of electron where we can find the maximum probability of electron. So s orbital is defined as the area where we can find the electron, probability of finding an electron is maximum. So the two s orbital, or we can say the two psi function, or the two psi function will going to have a mixing or combining together. They will have the two different interference, constructive interference and destructive interference. So very first, I'm going to talk about constructive interference. So when we are going to have a constructive interference, this will form a shape like this. We are going to have a shape like this, and this will be our internuclear axis, we could say. And we are having it, we define it as a psi 1s. Okay, psi 1s, psi means sigma 1s. What is the sigma? This represent the overhead overlapping of two atomic orbital. Okay, so, and what if I'm going to talk about destructive interference? This destructive interference would be like this. This would be like this. This is our internuclear axis, and here we will get a nodal plane. Here we will going to get a nodal plane where electron won't reside, and electron will stay apart. There less area, and when the area would be very less for electron to reside, then there will be the repulsion, and when the repulsion will be there, it will going to repel, electrons will be get repelled, and hence these two orbitals, these two from the atomic orbitals forming from the destructive interference will won't participate in bonding. Hence, that's why it is also called as anti-bonding molecular orbital, because these two atomic orbitals won't participate in bonding. And if I'm going to talk about this two atomic orbital, they are called as bonding molecular orbital. Those atomic orbital which are participating in bonding, which are responsible for the bonding. Exact uh, to be the correct way, the those atomic orbital which are responsible for bonding are called bonding molecular orbital. Now next, I'm going to talk about pz plus pz atomic orbital. Okay, so shape of p orbital is dumbbell shape, and we know why I'm talking about pz and pz. Actually, pz are the those z axis, the where the p orbital exists at the z axis is responsible for the sigma bond or overhead overlapping. Okay, so here pz orbital are responsible for the formation of sigma bond or overhead overlapping. So first, I'm going to talk about this constructive interference. First, I'm going to talk about constructive interference. When I'm going to talk about constructive interference, the orbital shape would be like this. This is the maximum probability where electron can reside. This is the maximum probability where electron can reside. That's why it is bonding molecular orbital. Okay, so from the constructive interference of two p orbitals, we are getting this shape, a new bonding molecular orbital. And from the destructive interference, we are going to get, see here, the electrons, oh sorry. This would be positive, positive, negative, negative, and it is nodal plane. So here just understand that two when two atomic orbital was combining with a destructive interference, there was a very less area left for the electron to reside. Hence, electron will try to reside away from each other, away from each other. So electron will be in the these parts, in these parts. Electron will be would be in these particular these parts. Electron would be in these parts. Hence, because why electron would go away from each other, because there is less area to be uh, very much less area left for the electron to stay at that particular area. That's why electron will go away from each other, and it will again not going to participate in bonding. Hence, we call it as anti-bonding molecular orbital. And last, we have learned about the PP head-on overlapping. Now I'm going to talk about PP sidewise overlapping. Sidewise, when it forms like this, sidewise overlapping. How I'm going to get this? Px plus Px. So for the constructive interference, this is known when these two having like this. If I'm going to go, the two orbitals are overlapping with each other like this. This particular area, dumbbell shape, we can understand the dumbbell shape. So dumbbell will going to have like this, and some particular area would be left at the center because the overlapping is something like this. So this would be left, that particular area. So the new atom molecular orbital we are going to get is like this, and it would be like this. Then I could say plus plus minus minus, and this will be our. So this is how we are getting a positive, sorry, constructive interference. And if I'm going to talk about destructive interference, then here the destructive interference would be like this. The area where electron could reside would stay away from each other as far as possible. So this will be positive, positive, negative, negative. Just I said that electron will try to stay away from each other at maximum distance. So I have shown it like positive, positive at the maximum diagonally they will be away from each other, and negative that diagonally they would be away from each other. And this is how we are forming pi bonds. And they are responsible for the formation of pi pz molecular orbital. And this we call it pi star, sorry, it wouldn't be pz, px, sorry, px, and this would be pi star px. This star I am showing here also, I have missed sigma star 1s. Here it would be sigma star pz, and here it would be sigma pz. Okay, so we are going to define it like this. Atomic star means if I'm going to give a star to it, then it is forming a anti-bonding. It means anti-bonding. Okay, thank you so much for the topic is literally a very difficult one. Why just to understand the the combining of two different atomic orbitals to form a molecular orbital and what could be the shape. So these are not the shapes; these are just the probability area where electron could reside easily. And when there would be destructive interference, there very much less area left, and hence the electron will stay away from each other so that there would be very much minimum repulsion. Next topic, I'm going to talk about reaction mechanism. If I'm going to talk about reaction mechanism, it is a very simple topic, but the most important topic because the whole organic chemistry has been just revolving around this reaction mechanism. And why this is important, just make me you understand that why this topic is important. So I'm just going to reaction of RBr plus NaOH. So what will going to happen that this Na would try to abstract this Br from alkyl group, and it will form ROH plus NaBr. So the reaction mechanism means the everything, the every step which is happening regarding from the removal of Br through to the addition of OH. This reaction is substitution reaction. So I'm going to talk about substitution. Substitution means to replace someone else with yourself. Okay. So here OH is replacing Br. But how this is happening? How this is happening? So there might be the two ways. There might be the two ways. I'm just talking very basically. Okay. There might be the two ways that first we are going to get away from it our alkyl group and it form positive, or let's take example of CH3Br. So what are the chances that this Na positive and OH negative, this Na positive influence Br and Br gets removed first to form CH3 positive, that is carbocation, and then NaBr is going to form. NaBr is going to form with OH left out. Now this OH will going to the CH3 positive to neutralize it and form CH3OH. This could be a way. Okay. What could be the another way of adding OH to the Br? Another way could be this Br is going out from carbon and this OH is incoming to the carbon. So One is going out and one is incoming. This we call it as transition state. We call it as transition state. And when one's transition state completes, this state where carbon having a charge over it, we call it as intermediate. We call it as intermediate. Okay. So before learning this, we have to understand before learning transition state and intermediate, we need to learn that how a bond breaking take place. So first, I'm just going to talk about what is an intermediate and transition state through a graph. If I'm going to take example of a graph, if reaction is proceeding like this, here the reactant is getting changed into the product. At this point, I am getting transition state. At this point, I am getting intermediate. And this again, I am getting transition state. First, reactant changes to the product by getting some activation energy, and when reactant reaches the activation energy, it goes now it start losing the energy and forming the product. Okay, but here the thing is happening when reactant is at its complete at the activation energy. Here the reactant is going through a transition state where product is going to form or something is bond breaking is taking place and new formation bond formation is going to take place. So always it is happening. First, always a reactant will change into the product when the previous bond, the old bonds will going to break and the new bonds going to form. So let's talk about when reactant is getting changing into the product. So here what we are seeing that reactant is moving towards the activation energy, and at some particular point it just lose some energy and again gain some energy, and this particular point is intermediate. Means intermediate are those species which are somehow stable with respect to the transition state, and they do exist for some fraction of seconds, might be they do exist, and yes, we can use it accordingly also. So we can define it that the intermediate are more stable species which forms during the during a reaction when reactant changes to product. And it doesn't mean that it always happen. No, it's not important that always an intermediate will going to take place. It depends on the mechanism and reaction that will we are going to study further. So before understanding this, we are going to talk about intermediates. I'm going to talk about intermediates. There are two type of intermediates. Sorry, I'm going to talk about intermediates. But before going to talking about intermediates, we need to learn the bond breaking, because always remember, when an old bond won't break, new bond won't be formed. Obviously, we understand that first old bonds going to break and then only the new bonds will going to form. So there are two types of bond breaking. First, heterolytic, and second is homolytic. Heterolytic bond fission and homolytic bond fission. Let's assume let's assume that something is getting divided between two brothers. Something is getting divided between two brothers. Let's talk about the pack of chocolate. Pack of chocolate. If your father is going to give more chocolate towards uh, elder one, what you are going to say? He is elder, he is more powerful, That's why he is getting more chocolate. And I am weak. That's why I'm not getting the uh, same amount of chocolate. Okay, so this type of bonding we call it as heterolytic bond fission, where the distribution of electron after breaking of the bond is not equal. For example, if I'm going to break carbon and Br bond, we know very well that Br is more electronegative. Hence, this Br will going to take all the electrons from carbon. This Br will going to get all electrons from the carbon and would form CS3 positive. Why this would be positive? Because carbon, when the electron that the one electron from the carbon has now been transferred to the bromine, and carbon now become electron deficient. And you know this very well. When negativity goes out from someone, the positivity left. Here, the positivity is not good in chemistry, but in real life, obviously, when you are going to relieve the negative charges or negative thing or negative vibe from all around yourself, then you are going to left with positive vibes only. Okay, so here CS3 positive and Br negative. Why this is negative? Because Br just seek the electron which is negatively charged and took it over itself. Hence, it is becoming Br negative. We call it as heterolytic bond fission because all electrons has been now transferred to the Br only. That's why it is heterolytic bond fission. And if I'm going to talk about homolytic bond fission, homolytic bond fission is happening between the two same electronegative difference when two atoms having the same electronegative difference. Okay, doesn't matter. Even it happens in HBr in the presence of light, peroxide, or different factors are also responsible for this HBr free radical formation or HBr homolytic bond fission. But we are going to discuss it later in the carbon free radical. But at first, what is homolytic bond fission? When the electronegative difference between two species is equal or two atoms are equal, the electron will be divided equally. When two brothers are same powerful, then obviously they are going to divide equally because they know that if he is particularly the person who is in front of him is same equally powerful, so it is better to divide half and half. So here the electron will be divided equally and it will form carbon free radical. From the homolytic bond fission, keep it in mind that free radical form, and free radical are the neutral species, but they are highly reactive. Why they are highly reactive? Because they just only need one electron to complete their octet, and hence it's make it very much highly reactive species. So further we are going to talk about in intermediates. So there are three types of intermediates. Actually, there are totally five types of intermediates. First, carbocation. Second, carbanion. Third, carbon free radical. Fourth, carbene. And fifth is nitrene. Carbocation when carbon getting the positive charge over it. Carbanion when carbon is getting the negative charge over it. Both of this form by the both of these formed by the heterolytic bond fission. What are carbon free radical? I've just told you it is formed by the homolytic bond fission. And what are carbene? Carbene when an carbon gets two free radicals. Two free radicals. It means when two different homolytic bond fission are happening in the same carbon atom, it will form two different free radical. So Uh, for now, this is only it from my behalf. And let's have some discussion over it about, first of all, the very first, the passion for chemistry. I'm talking about the chemistry is something which is very much a beautiful subject. Why chemistry is beautiful subject? Because everything around here, what we are, uh, let's talk about everything which is happening around us, like from the cooking food or the photosynthesis. Okay, so photosynthesis, digestion, which is happening inside us. The HCl breaks the bond and helps in digestion. Every reaction is happening inside us when we are going to breathe the oxygen. The oxygen helps in oxidation. Okay, the glucose is breaking it down. The glucose getting break down to form carbon dioxide, and we release carbon dioxide. Everything from the breathing to walking and everything, it is all because of chemistry. So understanding chemistry, it's a very beautiful thing. When you are going to understand the chemistry, you are going to understand the mechanism of our body, even not only the body. Just talk about the car you are in, which you are traveling here and there. The paint over it, the paint over the car, the very small part I'm talking about, the paint over the car is due to someone have researched that this type of paint is very much good for the cars, which will also give the shiny look to it and also does not wear it off very easily. So this is because of chemistry. So understanding chemistry makes us understand the what is everything going around us. So if you are going to understand the chemistry, this will going to help you a lot to see the world with different eyes and with different concept. So your participation for the knowledge is very much important. For your knowledge, sorry, your participation in the learning of the chemistry subject is very much important to make develop some understanding regarding this world and what is happening, what all those mechanisms are happening around us. Okay, so I'm going to, if I'm going to talk about a learning pace of the students, the learning pace of every student is not same. So, what is my way to make the students understand that how you can learn, how I can make them more presentable, or I can say I can just go with their pace. So, I've tried a way where मैंने एक चीज करा था, मुझे याद है, देयर वाज अ स्टूडेंट who is getting constantly 170 to 180 in chemistry and even in physics, and in bio he was getting 300 plus every time in NEET, particularly in NEET subject. What I did, I just asked him कि बच्चे तुम्हारे जो भी डाउट्स होंगे ना, we are going to have a different class, have a different session for you. ठीक है? और ये बात मैंने क्लास में नहीं बोली, मैंने उसको पर्सनली बुलाया, मैंने उससे पर्सनली बात करी, मैंने बोला तो क्लास में सारी चीजें कवर करना इज नॉट इजी, हमें क्योंकि सिलेबस भी कंप्लीट कराना होता है, एंड आई वॉज वेरी मच फ्रैंक अबाउट दिस टू हिम. तो मैंने बोला जो टाइम हमारे पास रहता है ना, जैसे लंच टाइम हो गया, लंच टाइम में वी आर हैविंग सम 15 मिनट्स लेफ्ट, तो उस टाइम 15 मिनट के लिए आके यू कैन आस्क मी द डाउट, और द डे which is you are having the off, that off day you can come to me and collect your doubts and ask me, सो डैट जिससे कि बाकी बच्चे हैं क्लास में ऐसा ना हो उन बाकी बच्चों का कि उनका लाइक दे फील मोरली डाउन कि यार उसको इतना आता है. ऑब्वियसली सम स्टूडेंट्स आर वेरी मच ब्राइट, जो पसंद करते हैं कि वो सारी बुक्स कंप्लीट कर दे. आई एम टेकिंग राइट नाउ नीट क्लासेस, एंड वो जो स्टूडेंट है मेरा, ही इज सो मच ब्रिलियंट कि वो मैक्सिमम बुक्स वो खत्म कर चुका है. ही इज मोर ईगर कि नई कॉन्सेप्ट आए, नई चीजें सीखे, एंड उसका ऐसा रहता है कि सर से मैं कुछ नई चीजें सीखूं. तो मैंने उसको क्लियरली बोला कि जब भी टाइम होता है आपके पास, आप आओ मेरे पास बैठो, हम एक नया कॉन्सेप्ट करेंगे और फिर हम नई चीजें पढ़ेंगे. मैं उसकी क्यूरियोसिटी, उसके डाउट्स, उसके जो भी है, अगर ही इज गोइंग फास्टर, मैं उसको स्लो करता हूँ बाय गिविंग सम एक्स्ट्रा वर्क और गिविंग सम डिफिकल्ट क्वेश्चन, जिससे कि वो क्लास के पेस के साथ मेंटेन हो सके। ऐसा ना हो कि वो बिल्कुल आगे निकल जाए और बाकी बच्चे मोरली डाउन हो। दिस इज माई वे वेयर आई पर्सनली कॉल द स्टूडेंट्स, सो दैट अब जैसे कुछ बच्चे ऐसे होते हैं जिनका पेस बहुत स्लो होता है, दे आर स्लो लर्नर्स। Slow learner doesn't mean they don't understand the concept. They understand the concept, but little late. So ऐसा नहीं है कि हम उनको छोड़ दें, ऑब्वियस सी बात है। इट्स आवर ड्यूटी कि हम उनको पेस में मेंटेन करके ला सके और हम उनको अपने साथ खींच के ला सके। सो मैं कैसे उनके लिए हाउ आई हेल्प देम, मैं उनको बुलाता हूँ, एक्स्ट्रा क्लासेस उनके लगाए, उनको बोला ये क्वेश्चन करो, इस टाइप से क्वेश्चन करो, टाइम देख के क्वेश्चन करो। So this way I can make both of the students can having a equal distribution of knowledge and equal pace, so that learners can't be get away from the subject, and the very fast paced learners don't they don't get a chance to make other one morally down. तो हम इस तरीके से, मेरा ये तरीका है बहुत अच्छे से करने का। एंड द नेक्स्ट वन इज हैंडलिंग द डिस्ट्रप्टिव स्टूडेंट्स। सो एक बहुत यूनिक वे है विच कैन बी अडॉप्टेड बाय एनी टीचर। डिस्ट्रक्टिव स्टूडेंट्स मीन दोज स्टूडेंट्स हु डज नॉट वांट टू क्रैक दैट एग्जाम। उनको वो एग्जाम क्रैक नहीं करना। They are just here because of some peer pressure or the pressure from the parents, or they want to, but their nature is like to having a fun in the class। जैसा स्कूल सिस्टम में हमने देखा है कि बच्चे एक्चुअली होते हैं एंड स्कूल में बहुत जगह स्ट्रिक्टनेस अलाउड नहीं है, तो बच्चों ने डरना छोड़ दिया है एंड दे लव मोर फन इन द क्लास। इन बच्चों को संभालना बहुत ईजी है। जस्ट टॉक टू देम, टॉक टू अबाउट देयर इंटरेस्ट, उनको किस फील्ड में इंटरेस्ट है, वो लाइफ में करना क्या चाहते हैं। द डे यू आर गोइंग टू अंडरस्टैंड वॉट दे रियली लाइक, और जब हम उनसे उस फील्ड के बारे में बात करेंगे कि यार इस फील्ड में यू कैन डू दिस थिंग एंड यू कैन डू अचीव दिस पार्ट, ओके, वहां पे वो बच्चे क्या हो जाते हैं फिर कि उनको लगता है कि यार कोई तो हमें समझ रहा है। At that particular point, that student won't disturb your class, won't disrupt your class at all। हम फिर उनको ये समझा सकते हैं कि how you can bring science into your field, how you can bring science into your knowledge, and you can make the use of science in your future for this particular area where you are more interested। एट दैट पर्टिकुलर पॉइंट वो सोचेगा कि कोई तो हमें समझ रहा है, कोई तो हमें जान रहा है कि हाँ हमें करना क्या है। सो इट इज अ ड्यूटी ऑफ टीचर नॉट ओनली टू टीच द सब्जेक्ट बट टू अंडरस्टैंड व्हाट योर स्टूडेंट वांट। इट डजंट मीन इफ योर स्टूडेंट इज having the science background or going to becoming an aspirant of JEE or NEET, it doesn't mean he want to do that only। हमें वो समझना पड़ेगा, बीइंग अ टीचर हमें ये चीज जानना पड़ेगा कि वो बच्चा करना क्या चाहता है, एंड वी हैव टू गाइड देम अकॉर्डिंगली कि हाउ यू कैन इनकॉर्पोरेट फिजिक्स, केमिस्ट्री, मैथ्स और बायोलॉजी इन योर पर्टिकुलर फील्ड जो तुम अचीव करना चाहते हो। फॉर एग्जाम्पल, अगर कोई बच्चा स्पोर्ट्स में इंटरेस्टेड है एंड स्टिल वी आर हैविंग फिजिक्स, केमिस्ट्री एंड बायो और मैथ्स, आई एम बीइंग अ केमिस्ट्री स्टूडेंट, आई कैन मेक हिम अंडरस्टैंड द यूज ऑफ न्यूट्रिशन। कौन से न्यूट्रिशन किस तरीके से हेल्प करते हैं, कौन से न्यूट्रिशन का क्या इफेक्ट होता है, साइड इफेक्ट होता है, क्या होता है। इफ सम स्टूडेंट इज मोर इंटरेस्टेड इन जिमिंग एंड ऑल, मैं उनको बता सकता हूँ कि हाउ रिएक्शन इज गोइंग टू टेक प्लेस, हाउ बॉडी इज अडेप्टिंग डिफरेंट फूड आइटम्स, कैसे तुम अपने जिम में क्या कर सकते हो क्या नहीं कर सकते रिगार्डिंग द केमिस्ट्री। सो वो सीखेगा, वो अब समझेगा, अंडरस्टैंड करेगा, और वो फर्दर ही वोंट और शी वोंट गोइंग टू डिस्टर्ब द क्लास at all, because they are going to develop some interest in that subject, because you have now made him understand the use of subject is not only for the competitive part but also in the life, okay। Next, my experience for explaining a difficult topic to them and the feeling I received that time. So I remember the topic that was buffer solution and the pH of buffer solution, where students couldn't understand at very first. But when I was teaching, I have chosen a very layman language. मैंने उनके लैंग्वेज में ही उनको समझाना चाहा कि भाई बताओ, ऐसे करेंगे, ये करेंगे तो क्या होगा? तुम अगर इसके साथ मिल रहे हो, मैच कर रहे हो तो क्या होगा? वहां पे पहले मुझे लगा that they didn't understand the topic because their face was numb, very much like they're okay sir, okay sir, okay sir. I was so much like lacking the confidence that time because इतने अच्छे से डेली लाइफ एग्जांपल लेकर के मैंने बफर समझा दिया बट दे डिडंट अंडरस्टैंड दैट. बट व्हेन आई आस्क द क्वेश्चन, आई एक्चुअली my habit is while teaching, when I see the numb face, without asking them, I again start teaching the same concept, the same thing with a different example so that they could understand. पर जैसे ही मैंने दूसरा एग्जाम्पल लिया तो बच्चों ने बोला, सर फर्स्ट एग्जाम्पल वाज बेटर, उससे हमें समझ आ गया, आपने ये बोला, ये बोला. मैंने आई आस्क्ड एवरी स्टूडेंट that what you have just understand, what is the buffer solution, what is happening, why the pH is resisting the change and everything. At that particular point, जब बच्चों ने explain करा, मैंने लगा, okay, so I was the person who didn't get that. I make them understand the topic very easily, and that was a difficult topic. Buffer solution is a difficult topic to make the 11th class student understand because physical in itself is something they try get away from the physical chemistry, and still I just made them understand the buffer solution very much easily at the very first time, at the with the very first example only. So that feeling was so much good that yes, if they can understand these difficult topics, it's only about the teacher who's teaching them. They have to take a good example or the perfect example which comes with an experience, that how you can going to teach buffer the difficult topic with this simple example, and this come only with the experience only. Okay, so how I can develop the love for the subject in the students. I just told previously that chemistry is very beautiful language where I can teach them, I can make them understand that in the which field or which areas we can use the chemistry so much easily, and where we can impart the chemistry in our daily life. जब हम बच्चे को डेली लाइफ रिगार्डिंग या उस बच्चे के इंटरेस्ट रिगार्डिंग हम एक सब्जेक्ट को डेवलप करते हैं, ऑब्वियसली इट इज नॉट इजी टू अंडरस्टैंड और मेक डेवलप सब्जेक्ट नॉलेज around every single student in the class. Obviously, this is not at all practically possible. But yes, being a teacher and in, going with the same generation, we see what is happening around us, and we have a collective data that where the students are more leaning towards, where this generation is more leaning towards. And when we are going to take example from these particular areas and the application of chemistry subject in these particular areas, then it is very much easy for develop the subject, the love for the subject in the students easily, and making like also the we have not only to develop the subject love for the chemistry subject also, but we have to love make them develop the learning habit also in them, and this learning habit can be developed by making them understand what is the use of knowledge, what is the power of knowledge, how you can use that power, you can impart that knowledge in the different field where you can find the success in your life. So that was my total uh, my actual who I am and how I am going to teach student, and how have I have been teaching the students in the class. It is totally in front of you now. So these are my ways, and this is how I always work in the class. My father had been retired professor, and I have seen him teaching very much, uh, and even my father was also teaching me in the house. So I know how things can be delivered and how things could be delivered to a student so that a student could get a success, could achieve something better in life. Thank you so much.